I'm Rudy de Busser. I'm working for Payara as developer advocate and also in the service team responding to customer questions. And we have also Ottavio here today. So just a short intro of you, who doesn't know you, Ottavio.
Hello everybody, my name is Otávio Santana, I'm from Brazil. Yes, I'm wearing pajamas because, stay at home the whole time. And I'm also glad to be here. Thank you, Payara, for the opportunity.
Okay, quick look at the agenda. As you have you have seen in the registration, we will tell you a bit about cloud and cloud native. A few words about Payara Micro and what specific features we have for Payara Micro in the cloud. And then Ottavio will take over and tell you the concepts of Platform.sh, why it is so special and why you should use it. And the demo, of course, with Payara Micro, it will be a live demo, so very excited to see all those things in action. So first, cloud, as you know, it is basically just a move from your application on an on-premise service to a larger data center. And with cloud, those hardware stuff is brought to you via the network. So you have most of the time a GUI where you can define your requirements for your server, like CPU and memory requirements. And with a click on the button, you receive then a few minutes later your environment that you can use. There are, of course, benefits in this way of working, mainly because you have a faster setup. You don't need to order your server anymore, wait until it's delivered and put it in your data center. So you decide, I need a server, and a few minutes later you have one. Also, that flexibility comes with a reduced cost because you can exactly determine the required sizing of your machine. And later on, a few months later, you can say, oh, but I need some more memory. And you can just go back to that GUI and just update your memory requirements and all is set. And you have your security requirements, which is also covered in larger parts, because the upgrade of the operating system, for instance, is handled by your cloud provider, and thus you don't need to take care of that, and it's all done for you, which is of course easy and handy and comes within the package. There are different kind of cloud models. And I'm showing here the graphic of which Ottavio made, which is a very nice comparison with a pizza as a service. But the models are, at the first level, you have infrastructure as a service, where you only take the hardware, the server, the network from your cloud provider, and you as a user is still responsible for setting up your application server, your Payara server, for instance, configuring it, connecting to the database, and deploy your application. That's the infrastructure as a service, the take and bake in the pizza comparison. The second level is the platform as a service, where you not only use the hardware, but that the cloud provider is also responsible for installing your server and updating it, for instance, every time there is a new version. So then it brings only the responsibility for you to update and maintain your application, your data. And the last level is the more specialized version, that is software as a service for specific cases, like your mail provider, where everything is handled for you. You just need to connect to the system, configure your account, and you can go. The data, the mails, everything, the application, all is handled for you. You don't need to do anything. That is when you go to the restaurant and everything is brought to you on your table. So most commonly that the infrastructure as a service or platform as a service are used by the users, by customers, so that the provider manages the hardware, operating system, and the server runtime. Next step in this story is the cloud native. And cloud native is a bit of a term which is not defined very clearly. It's a vague thing of what is exactly cloud native. The basic thing is that you always use the possibilities of that cloud deployment that we described in a minute. So you are taking advantage of the possibility that you can manage your complete environment through the GUI, or in most cases also through a command line interface, which means that you can create some scripting. So your operation and your DevOps becomes not only for your application, but for the entire system. So you can, with one script, create new instances for your test environment, deploy it to the test, and move to production if everything goes well. So that means that cloud native is also related to what's called continuous integration, continuous deployments. You just do a commit, and if everything goes well, it appears minutes later in production. Most of the time, containers are used for this, like Docker containers, because it is easier to just move a container from your test to production environment, because that's a fixed, stable set of resources, and you have tested them in your quality environment. So moving that to a production environment makes sense, because then you can be pretty sure that it should also work in production if you have done all your configuration of those environments correctly. Of course, that in production you connect to your production database. Also, microservices is related to this trend of cloud native, because with that cloud, that continuous deployment, it is easier to put something automatically in production if it is small. It is better testable. It is better contained. You can do those things more easily. You can automate those things more easily if it is smaller. So that's why microservices are also used in one term together with cloud native. But in general, for any of your applications, the 12-factor applications are, of course, suited, because they make sure that all the things that I just told you about continuous deployment, configuration, etc., will be possible, but more on that later in this presentation. So I mentioned microservices, and they are smaller because they are focused on business domain. It is not that they are only one or two classes big, so you should not try to minimize everything in different microservices, but try to group them by a business domain, for instance. And then you have a set of loosely coupled services, which you can, as I said, put easily into production because they are small. They should be independent, which is not always easy to do, because you have also other microservices or clients connecting to that service. So you need to make sure that all those things are backwards compatible, and maybe you need to maintain multiple versions of your microservice, because not everyone can change immediately together with your update of the microservice. So that means that you would end up with a monolith again. But there are also drawbacks related to microservices. And one of the things is, of course, communication overhead. You always need to call other microservices to receive your data that you need. So you have always those calls, those overheads, which are no longer within the same JVM, but outside with a REST protocol, for instance, so that takes more time. You also have a larger attack service because you have all those different microservices. So it's not only one port that you open up to the world, but maybe you open up 10, 20, 50, 100 ports. So you all need to make sure that security is handled very well. And handling only one monolithic deployment or handling 100 microservices, that means that your management takes, of course, a lot of more time and a lot of more planning. So microservices are great in some cases, but try to find the correct balance between the things that you need to do for your situation. Now let's get a bit more concrete and let's switch to the Payara platform. We have two main products there, and the first one is the Payara server, the classic full-blown server application that you download, install, configure, and you can deploy applications to it. It is Jakarta full compliant, so it is tested. It is according to the specification. So you can use all that information, all that Java EE and Jakarta EE background to run your application on the Payara server. More on that also later. But we also have a specific version for those containerized microservices deployments, as I spoke about in those cloud native scenarios. It is smaller because we do not put the full profile there in Payara Micro, because remote EGBs and SOAP is not a thing that you usually use within microservices. So the smaller, specific for those cloud environments, faster startup because there is less classes, less frameworks that need to be started, etc. There are also specific optimizations for cloud, which come to in a minute. We have the bit at Payara Micro, the option which is called the hollow jar technology, an executable jar file. So you start up with Java -jar, and then you point to the jar file containing Payara Micro. So you do not need to install it, you just run it. So that's why they call it runtimes, server runtimes these days. And when you start it up, you point to a WAR file that you want to run, your application. So by splitting up that server, that Payara Micro, and your application, you can have an optimal layering system in your Docker images. Because when you change a line in your application code, only the WAR file needs to be changed in your Docker image, and that means less transfer of data, faster startups, etc. We have also something which is called a data grid, which is available within server and within Micro. Where you can exchange data between instances, which of course becomes important if you are running in a cloud and maybe you are using clustering because you have high demands, high loads on your service, so you need more than one server instance to do all your requests, to answer all those user requests. The data grid looks a bit like this. So Payara Micro has an access to it, and your application can put something in that data grid. The first instance can put there something, and that can be some data or read something of data which is not changed often, as for quite static data, or data related to your customer. We don't have a session object in REST endpoints, but you can keep some data related through your security. You know that a certain user is accessing your endpoints. So that information can be put or read from the data grid, and instantaneously all the other instances linked to that data grid can also use the same data. So if there is a new instance coming up, they can join that grid, and all things can be shared without any action from the operator or the one who maintains the system. There are other things that are done specifically within Payara Micro for the cloud, like integration with volumes, so that you can put data on the volume so that it can be shared or persisted when your Docker container goes down. Or links with Kubernetes secrets so that your access to your database, the passwords, etc., are safely stored in those secrets. And as I mentioned in the previous slides, the scenario with the horizontal pod scaler with Kubernetes works also because we make sure that when Kubernetes starts up another instance of Payara Micro, that it joins the same cluster so that you don't need to do anything, so everything can be done automatically in case the system Kubernetes detects a high CPU usage of your current systems. I mentioned Jakarta EE already before, so if those who are not aware of it, it's the new name of Java EE under the Eclipse Foundation. So it is all related to enterprise Java, the set of specifications and standards which are followed by every Jakarta compatible product, like Payara server is one. And you have one API, one specification. You can have multiple implementations, like Payara is one, but you have now already 5 compatible products these days. And now that it is under the Eclipse Foundation, it is a completely community-driven collaboration. So it is not owned by a vendor anymore. So it's not Oracle who is owner of Java EE, but Jakarta EE is completely under the rules of the community. And a few people think that Jakarta EE or Java EE is not important anymore, not relevant, but I've put here a few specifications. I've listed here a few specifications on the slide, like servlets. I think every major framework today which is dealing with HTTP is using servlets. JAX-RS, the REST endpoints is used by many kinds of products and frameworks. JSON processing and binding, security. So JPA, for instance, with Hibernate. So Jakarta EE specifications are not only important for the Jakarta compatible products, for their own product, but is a major part of the Java enterprise community these days, and so very important to the whole system, not only Jakarta. So if you like to move it forward, you can always join us within that Eclipse Foundation and drive it forward now that it is a community thing. I also mentioned MicroProfile in one of the slides, available within Server and Micro, but mostly used within Payara Micro. Because with that Jakarta specifications, you can, of course, create your applications which then are deployed within the cloud. That's not a problem. But a few goodies are missing for the distributed environment, for your microservice environment. Things like fault tolerance, where you like to retry your connection from one microservice to another because there was a network failure, a temporary one, or there could be other temporary things going on, which happens in those distributed environments. Things like open tracing, so that you can debug your requests easier, because now it's not only going within one JVM, but you cross 10, 15 different microservices maybe. So it is good to have a tracing where it all goes, and so that you can follow it. Probably find also some bottlenecks. What is the slowest part of your request handling? Things like a job token for security, because the last service in the chain needs to know for which user that initial request was made, if it's allowed even to give you that data, etc., etc. So all those goodies and more of that are available in the MicroProfile specifications, which is also a group of more or less the same people working on Jakarta, but this time it is geared towards those microservice environments. The goal is also different. Jakarta was more a stable thing. The idea is that with each release, your applications should still work without any change. So you have even backwards compatibility until the beginning of times, the Java EE 1.1. Here with MicroProfile, it's more the innovating things, because microservices, we are doing it maybe only 5 years and not 25 like we do with enterprise things. So it will have more breaking changes, not always backwards compatible. And you sometimes need to update your application when you change from one version to another version. So Jakarta EE and MicroProfile comparison, they have different goals, but that doesn't mean that you cannot combine them. We have combined them within Payara Server and Micro. We are not the only one who is doing that, so that's nothing special. But be aware that if you are using MicroProfile within your application, and it can also be within your Jakarta EE application, like something like config is very useful, for instance, that it is possible that you need to adapt your application when you move to a newer version. So that was a short intro from me. I'm giving the screen and the sound to Ottavio so that he can tell you all about the Platform.sh environment.
Okay, hello everybody. Thank you, Rudy. There's a hello from Brazil. So guys, where are you from? So please answer me. Let's do a conversation. Why not? Oh, Vitor. Olá, como está, meu amigo? Me gusta muito México. Afonso, Holland. Okay, guys, it's nice to be with you, Brazil. I love Brazil. I'm from Brazil. Eu também falo português, obviamente. Russia. I'd like to go there. So, guys, that's nice to be here with you. This moment is so important to everybody to, keep the mind, think about the technology, and learn something. Keep the whole mind busy. Oh, Portugal. I'd like to go to Portugal again. Eu amo muito o Museu de História em Lisboa. I love so much the History Museum in Lisbon. I'm kind of musician guy, and anyway, that's nice to be here, guys. So if you have any question, please put there. That will be amazing to answer. There is no tough question, so if you have no idea, Rudy can help me, or maybe later you can write a blog post about it, right? But anyway, just returning to, can you see my screen? I think so, right? Oh, by the way, thank you, Payar team from UK, India, Croatia. Oh, that's amazing to see a lot of people around the world. But anyway, uh, if somebody do the question, what is cloud native means? As Brody said, that's hard to answer because everybody has your own definition. And as well, I have my own definition. I read um 7 books, I guess, and over 45 articles about cloud native. And that is what I have on my mind. So that's my own definition. So my suggestion to you is go through and do the same. Read a lot of articles, or maybe just waiting for a little couple years to everybody finally agree in one whole definition. So to me, it's a set of good practice to optimize your application in the cloud through containers, offshore, orchestration, and automation. Before I go further and deeper on platform message, I'd like to first do a little bit of live code because I'm a developer and I enjoy a lot to do live code, right? So basically, I create this sample this morning. Usually, I do Jakarta NoSQL with some NoSQL database that is usually, MongoDB because that is the most popular one. However, a lot of people complain and say, "Oh, Tavio, you just use MongoDB, or not? Why not change to another NoSQL database?" And guess what? I decided to change to another NoSQL database. Okay, as you can see here, basically I'm using a Maven project with my .xml file, and what I put here, I put 1 second. Let me share to you. I put my microprofile as provided in Jakarta EE API provided because I'm using Payara Micro. I don't need to hand about the dependencies. Payara Micro gonna hand everything to me. Okay, that's why I enjoy Payara so much because I don't need to. Okay, I'd like to use Jakarta and plus microprofile. So I have one flavor that is Payara that has everything that I'd like to use. As a dependency here, I'm not using anymore MongoDB. This one gonna be Elasticsearch. Usually the people ask me, okay, why it's an extension? Basically because Elasticsearch is a little bit more than a NoSQL database. Elasticsearch is a NoSQL database of document type and also an Elasticsearch engine. And to NoSQL database, that's really, really important to have support to particular behavior into a NoSQL database. So in this case, a search engine that Elasticsearch does, right? So in the code, it does not change a little, does not change much. Basically, I still have my configurations on the properties that I'm gonna overwrite on my cloud. I'm gonna show you later. So basically, I have my hosts instead of uh, a MongoDB host. This one gonna be a Elasticsearch host, and my provider is not a MongoDB configuration anymore. Guess what? This is gonna be Elasticsearch document configuration because we're gonna use Elasticsearch. In a code perspective, it does not change much. Basically, I'm using my config property to inject my manager and done. So as you can see here, I don't care each NoSQL database I'm using. Okay. So let's move on. Let's create first my entity. For sure, I'm talking about Payara. Let's create a microservice to handle fish, right? Why not? So I have my fish. This fish has one ID, so string ID. And my second one is the name, right? Usually you can use for sure DTO if you wish. You can use, let's put that here. You can use whatever you want to strategy. But just to make it simple, I'm gonna put getter, setter, and everything. At this moment, I don't care about OOP. For sure, on production, don't do that. I'm gonna put some toString here. Thank you, IntelliJ, to make that easier to me. Equals hash codes. I'm gonna use my ID for sure. It's done. So basically, I have my entity that I'd like to take there and convert this guy to, I can say that, an entity. Basically, if you know JPA, you are a little bit familiar with Jakarta NoSQL because I'd like to define these guys as an entity. So let's use the entity annotation, right? However, instead of Java specifics, we're gonna use Jakarta NoSQL mapping. Basically, because in Jakarta NoSQL, we have two mappings, two layers. One layer to mapping, where I input annotation, something like that. Another one is my communication layer that you can think about JDBC. Why not use the same annotation? Because JPA was created to SQL and Jakarta NoSQL was created to NoSQL database. That does not mean in the near future You can create a new specification or maybe just one API to have the annotation common. That you'd be amazing to make it happen. But now, for now, I'd like to define this guy as an empty, and the guy as a column. So basically here, I have my class annotated to use Jakarta NoSQL. That is the first specification for Jakarta EE word to make easier to you take your application and connect to a large search. I have my entity. Let's move on to create my repository. So it's a layer to fish repository. And the whole idea here is to create my repository to connect my fish entity to my database. I have two parameters like Spring does. The first one is my entity, the second one is my ID. Okay, so I have my entity, I have my repository. Let's move on to my research to create my first microservice of fish. Why not? So fish research. I'm gonna inject my repository. First repository. I'm using CDI for sure, so let's use inject. And then let's create the basic methods. So let's use here public, no, come on, public void create. Then I'm gonna create a fish. Come on, where are you fish? Repository save, right? Let's move on to return the whole fish that I have, right? Why not fish? Get all, return repository, find all, find all, right? So find all. Wait, I don't have this method, so don't worry. Basically, you can create a method that's gonna create automatically to you. So I have my find all. I can create. What else? Okay, I can find by ID. Usually I can do that. Fish, find by ID, string ID, repository, find by ID. This one I'm gonna return optional for sure. And optional, if you are familiar with Java 8, there's a good way to avoid null pointer exception. And usually when I'm talking about microservice, when I'm done with have the resource, I like to return for a 4, right? So let's do that. Fish, OS throw, new web application is not found. So basically, if I don't have the resource, it's gonna return for a 4 to me. And the last one is, okay, let's return. And the next one is delete. But let's skip delete because I don't have enough time. So I'm doing that, right? So the next step is basically to define this guy as resource. So let's define the path. This guy gonna produce JSON, media type JSON, and also it's gonna consume the something. And this guy gonna have the scope of application. Okay, I have my repository, and basically he is normal if you are familiar with Java RS. So post to create, get to return everything. And this guy is what? Oh, this guy is get also. However, it's gonna have a path to ID. Let's define here the path param ID. So basically what I have here, I have my entity, I have my repository to connect with that database, and I have my resource, right? And I don't need to handle about this. The service, basically I put everything here on my .xml. So what I'm gonna do next, for sure, I need to create my Elasticsearch locally first. So, okay, where's it writing me? Don't worry. I'm gonna put everything detail on my, oops, oh, here you go, is there. Basically, I'm gonna create my Elasticsearch locally to just run my tests. Okay, it's running. And then I need to come here and create my, as Rudy said, my hello job. That makes it easier to me if I want a first time take my application run. For sure, I have the buggy option to make that even easier. And let's create my first Java jar target. I get the name first. So it's gonna create to me my application, right? So it's gonna create my application, blah 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 blah. Come on. To make that easier, I already put some information database. Let's see. Oh, it's loading. Sorry for that. It's still loading. Okay, it's ready. Basically, it's loading information. There's nothing. Let's put my first information for sure. Gonna be my Payara, the first element of my collection, and then a goldfish, right? And then let's show the information again. So finally, I have two fish, so my Payara and also my goldfish. That's a search engine. That means you can put integration with search engine if you wish. I don't have enough time to make that, but for example, give that like to find out, however, return by order. So I can do something like that. So list, it's here, query, and can do something like select from fish, order by name. I can choose whatever I want. That's one option. And do you remember that I have support to Eclipse, Jakarta EE, and also MicroProfile? That means I can use something like, okay, Google Chrome. You should not do that. So let's cue the Chrome again. Cue all Chrome, sorry. When the presentation is finished, I'm gonna return, I promise. I usually don't do that, trust me. I usually be a good friend. So anyway, so I can do something like, okay, and right now I'd like to return by name or something like that. I just can use this guy here, so query. And you can compile again and then run the application again, and that is it. Okay, so basically you still have the same power to use your NoSQL application with Java Jakarta EE. With Jakarta NoSQL, I'm using Payara to make that really easier to integrate Jakarta EE with MicroProfile, right? As you can see here, I'm using MicroProfile to define the configuration. I can put a lot of information here, such as user, password, something like that. Wait. I didn't say that I can put password here. Yes, you can put to run something locally, right? we won't put some password on production in the code, right? So how should I do? The good thing about microprofile configuration is that you can override the information on environments. Docker has several nice features to make it easier. And now I'd like to show to you about how can I move this code easily to the cloud using Platform.sh. Okay, so we did the overview about Jakarta, NoSQL with Payara, and let's move on to move this guy to the cloud. So basically, to move to this guy to the cloud, I can use Platform.sh, that is a platform as a service. To make this possible, I just need 3 files. The first one is about my application, and it says how I'm gonna create my application, and then how can I run my application. Basically, this file here is to create my container and then execute my container, right? So have the name of the container application, the Java. I'm using Java 8, but if I wish, I can use Java 11, whatever I want. So the space, how can I build this application? So I'm using this MVN clean package. I'm doing the relationship with Elasticsearch. Why that? Because when I'm using, if you like to use containers, microservice, security is really, really important. What does that mean? You need to make sure that your application has the right access to the right database, right? So I'm doing this kind of thing here. I'm creating a relationship between the search and my last search database, okay? And guess what? What I'm doing? On the real-time Platform.sh is gonna give my credentials. I'm gonna receive it here and then overwrite on my real-time application. So basically here, I don't have user passwords, as you can see. However, here, I have user passwords that I have no idea, and also I don't need to. Okay? Basically, Platform.sh is gonna handle everything to you. The second one is basically service. Service, you can think about SQL database such as MySQL, MariaDB, whatever. NoSQL database such as MongoDB, Redis, and so on. So on this case, I'm using Elasticsearch, the version 7.2.2. And a host is basically if I'd like to do something, okay, I'd like to the default application, go through the app. However, if you have a lot of microservices, I can find basically just to my default application, have public access, and everybody else, I mean, other microservices to don't have public access. So just my public API have access to that. And security is really, really important to make it that possible. And as you can see here, it's smoothly. So I have these 3 files. So let's move on to the cloud. Basically, you can create a Platform.sh project, and they have 2 ways to connect. So Platform.sh needs a Git repository. You can use GitHub, GitLab, whatever one, or you can use the repository that Platform.sh gonna hand it to you. Okay. On this case, let me show to you. I'll use the private Platform.sh Git repository. But again, I can use, if I wish, GitHub, GitLab, whatever I want. On this case, I'm gonna put everything. Don't do that on production. So don't use command like that. So and then I'm gonna push to my cloud. But if you want, you can rename that as whatever you want. And basically, it's gonna create my container. with what I want. And how basically I'm using my .xml here. So it's basically distributing um, my Maven application. It's gonna run because they find this command here. It's done. Okay. Let me show to you. Let me show. I have several applications for sure. Let's take one here. Let's remember the name that I don't remember right now. I guess no, that's no. But anyway, basically it's gonna return. It's gonna create to you these containers. So let me show. Tomcat, I guess this guy here. So as you can see, I have several containers. So I have one container to the host, one container to the vanish. If I like to do something like my load balancing, I have my container of my application. I guess I have one more complex here. So let's go to my this little bit high guy here. So I have my host, have my Java application with several servers. The whole point here is I have my application and it's gonna create a container to me and move that to the cloud. Okay, that is the whole idea. Template, Tomcat, and blah 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 blah. So let's move on to the presentation again. And when we talk about clouds, the best analogy that I saw was about pizza as a service. Because if you decided to use, on-premise, that means you're gonna create your home pizza at home. But there is a huge risk to that, right? And also there is pizza delivery that is a low complexity and also a low risk. So if you are not a good cooker, if you do a delivery, there's no risk to that, right? And usually cloud is a little bit complex to make it happen. So Platform.sh was built to that idea, to make it easier to take your application and move on to the cloud based on 3 files, as I mentioned before. So we have support to more language. So if you like to move on your application to Python, PHP, whatever you want, just move it. So instead of the type Java, you're gonna put Python Java with the version that you want to run. And I know usually when you decide to move to cloud, you have monolithic application, so you can move on. Microservice, stateful, stateless, whatever you want. As I showed to you, it is infrastructure as a code. So basically I don't need to handle manually my application, my operation stuff. I just need to handle my file, right? And usually when I'd like to, have my staging environment on Platform.sh, I just need to create a branch and then push, and it's gonna create my environment to me. Based on that, you can deploy every time, anytime, even Fridays. Because on the real time, for sure, I'm gonna create a PR. There's somebody that is gonna review that PR. And when somebody decided to merge this code, it's gonna create to me, gonna deploy to me automatically and everything. And you can do deploy anytime, anywhere. So over 20 regions, a lot of cores, a lot of disk and storage. The whole idea is to take advantage of the application in the cloud. So you put this application, you define the files, it's going to create a container to you. You can use, as I said, PHP, Java, Node.js, Go, Python, whatever you want. You have support to several databases. you can integrate with continuous development deployment, and you get the container orchestration automatically. So you have infrastructure, the service, this kind of thing. And the whole idea of the platform stage is to take advantage of cloud easily. So you can integrate with GitHub, GitLab, Bitbucket. You can build with Jenkins if you want, or just run a deploy. You have partners, so if you like to use platform stage with Amazon, Google Cloud, Azure, Orange, whatever you want. So have this advantage to you. And for sure, we have several clients. So the economy is over 1,000 clients. And for sure, we have support to Java, right? That's why we're here. That's why I'm engineer from Platform.sh. So if you like to use MicroProfile, Jakarta EE, Turntail, Spring, Maven, Gradle, for sure Payara, and Tomcat, Cruzy, Wildfly, whatever you want. So you can also use Kotlin, some JVM language based if you want to. Okay, I already did the demo. And this Friday, by the way, we're gonna have open question and answer. Join us, that would be amazing. Okay. Oh, thank you, Roddy. Guys, let me close here my screen. Is there any question that you
Yeah,
can
so if anyone has questions about what we have told you, what you have saw, so please go ahead, and we still have a few minutes left, so.
Yes, just one point. I forgot to show the application itself, but that's is how it looks like. So I have my host, my application, and my Elasticsearch as a database. Okay, and let's stop this way.
I think there was a chap who wanted a link to the Git repo of the app example, if possible.
Yes, yes, for sure.
In the chat.
Yes, I'm gonna put there.
While you're looking.
Yeah. Sorry, Jaden, go ahead.
That's okay. Sorry. While looking for that, Victor asks, what is the best approach to deploy microservices connected to on-premises database? In the chat. And Ottavio has posted the link as well there, Alexei.
And also it has a link to the book, okay?
So Ottavio, is it possible to connect to on-premise databases? I think you just need to set the correct IP address and that's all.
Yes, you can do that. You can take your microservice, connect to on-premise. However, as I showed you, you have several databases. You can just move your whole data to Platform.sh and then use from there. But I know usually when you like to migrate, you'd like to migrate slowly. So yes, if you want to, you can connect your cloud application with on-premise database. That is possible. However, that might be a security issue because cloud used to be somebody else there. You need to make sure that IP is public, right? Something like that. But yes, you can do that.
And you have probably also some more latency, so it will be slower than when you host everything on the same platform.
Yes, that's a point also.
Any other questions?
Yes, there is one more. It's possible to deploy Payara Micro with Anjar as a native application.
Well, this example was one, because this was not a really hollow jar one, because you have built one jar file containing the Payara Micro runtime together with the WAR file all in one jar file. So this application was actually what the question is about. But as I said, in Docker, sometimes it's better to keep them separately to have better layering system.
Yes, you can do that with Docker and also in the platform stage. That's possible as well. Okay, that's true.
Hi Edwin, you're also joining. So
Hey,
question
Edwin.
is of Edwin, can you host your apps on Platform.sh and integrate on service on other cloud products? I think yes, but
Yes, you can, because Platform.sh is a platform.sh, right? So basically, you can integrate whatever you want, and also Platform.sh use some infrastructure as a service such as Amazon, uh, Microsoft Azure. You can think about a Java layer. So there is a platform.sh here, and we have infrastructure as a service that you need to platform.sh need to use. So yes, you can use.
also the question from Alexei, is there a big latency with on-premise database in the same data center? So maybe the question is, can you really control the region where your application is, where your system is deployed, your environment with Platform.sh, so that you know that
Yes,
it's shorter distance?
yes, you can choose. You can choose region. So if you are from Europe, you can choose the region of Europe West. If you are North America, you can choose North America to decrease the latency. You can do that. So let's show here.
There is a question about Payara Micro Docker image to be more
Okay, go ahead.
configurable. Yes, we are always improving it. For instance, we have now added the possibility to warm up so that you have so that you can use the class data sharing, but most of the configuration possibilities you have now already is based on that post-boot command file where you can configure everything already. But if you are thinking of some option that you need or require, so please let us know through a GitHub issue what your requirements are.
Okay, is there any more questions? Another question, Microsoft's MicroProfile does not have AGB container. Yes, you sure. If you talk about Payara, I guess if you choose Payara Micro, it has EGB Lite, right? So we still have support to singletons and program timers, right, Rudy? I'm not sure about this one.
Yeah, so officially the Jakarta EE web profile doesn't have EGB timers, but we have that within Payara Micro. So it is possible with our product. In general, it's correct that MicroProfile doesn't have an EGB, so you can't have programmatic timers. Singletons, you have this singletons are application scoped in CDI, so that's an alternative. We have within Payara Micro the clustered singleton, so even if you have a cluster of instances that you only have one instance across that whole cluster, that's also possible. But for that EGB timers, for those timers in general, then you need to use something else. That's for sure. If you're strictly working with MicroProfile.
What do you think about Quartz? When you talk about timer,
Yeah.
what do you think about Quartz? This might be a solution.
Yeah.
Yes, Platform.sh has one way to do that outside the code. So it's a cron that looks like Quartz, however, it's outside the code. So that's one option as well. And sometimes I saw somebody using Jenkins to make that possible. I'm not sure if that's the best approach, but there's a lot of people doing that.
You can also indeed put timers outside of your application and trigger then some action within your application. A question about to use credentials with microprofile configuration. Yes. As you saw already, you can define it outside of the application. That's one of the requirements of the 12-factor application. As I mentioned also in the presentation, with Payara Micro, you can put them even into Kubernetes secrets. So that's then probably the best way. Question about the good memory footprint config for Payara Micro with one and Dockerfile. I'm not sure what you mean with a good memory footprint, but yeah, it all depends, of course, based on your application, because most, except for, of course, the Hello World type style of application, but the most memory is used by your application, by your application code, like you're retrieving information from your database or the JNoSQL things. Those things need to be stored. So most of the time, that's the major part of your memory footprint. So so it all depends what your application and your requirements are there, the size. But something can be very small, or some customers are using some gigabytes of memory. But as I said, that's depending on the application.
Yes, unfortunately, there is no silver bullet when you talk about memory. Each application has your own formula.
Yeah, there is also the question of EGB async execution. That's the same asynchronous EGB is part of the full EGB spec, so it's not available within the web profile, not available in MicroProfile, and not available within Payara Micro. But you have the thread pools. So if you want to do something asynchronous, you can use the thread pools, but then of course it's not an annotation. Yeah, you don't have the managed executor, but you have just the executor service, so you can use the basic Java stuff to create new thread pools. And I have to look up, because managed executor service does ring me a bell for Payara Micro, so it might be possible that it is in Payara Micro, the managed executor service, but not the annotation, asynchronous. Okay, some nice questions. We are already 5 over, but 5 minutes late. Anyway, questions are there to be answered. So, anyone else? Some question?
Okay, guys, thank you for your time. Thank you, Payara. Oh, there's one more question.
Yeah. Can the data grid handle the executor on more than one pod deployed? A data grid is mainly for sharing data. It's not, if you go more lower level, because it is, then you can have your executors, but it's mainly for sharing data. So if you want to have something executed as a timer thing, then you should use that EGB timer, what I already mentioned, that is also possible within that data grid.
Yes, I guess that's going to be recorded. But anyway, probably Rudy and I are going to do that. I'm not sure yet, but probably on the Eclipse meetup as well.
Yeah, because that's a possibility.
So anyway, we're going to do that again and better. Okay, guys, thank you for your time. Thank you again, Payara team. Thank you, Rudy, and see you on Friday. And guys, join us on Friday. And thank you again for your time. Stay home, stay safe.
Yeah, same from me.
Thank
Bye.
you, everybody.